friends, welcome to VK lectures. In this lecture we are discussing 25 and 26 questions from Kset 2018 physics question paper. Question number 25. In the absence of an applied magnetic field, warm plasma can support both electron plasma waves and ion plasma waves. The dispersion relation for these two waves indicate that at large value of wave number k. So what is large value of wave number k? K is equal to 2 pi by lambda. So when k is large, which implies small frequency, or small lambda is becoming small, which means k is large. Okay, so at this frequency what is the change, and how can we find out the group velocity Vg is equal to d omega by dk, and here are the dispersion relation for electron, for plasma wave and for ion plasma waves. Omega square equal to omega p square plus 3 by 2 k square Vth is the electron thermal velocity. Okay, where k is the wave number. Here see s as the speed or the velocity, and according to the question we find the both frequency as well as the velocity, and here the option is option A for electron plasma waves. Electron plasma wave become the constant velocity waves. That means Vg equal to constant, and for ion plasma wave omega becomes constant. Okay, so option is option A. The wave equation corresponding to certain electromagnetic phenomena is given by this del square plus k is naught squared into E of RT equal to 1 by c square dou square E by dou t square, where k naught squared is real constant. Now an electromagnetic wave whose electric field is given E of RT equal to E naught e to the power I k dot r minus omega t propagates through the medium. E naught is a constant. Now you want to find out the relation between omega and k. Now E is given as E naught e to the power k dot r minus omega t. Now what is k? K equal to kx into I cap plus ky into j cap plus kz into k cap. Now, and what is r? R is a position vector equal to xi cap plus yj cap plus zk cap. Now we want del square. What is del square? Del square is nothing but dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Now we want del squared of E. Now for theory purpose we need to find out dou square by dou x square y and with respect to z also, but for competitive exams we just need to get the terms. So what we can do is we can consider k as k itself and r as x. So dou square by dou x square, so just rewriting our E in terms of k and x. Dou square by dou x square of E naught e to the power I kx minus omega t. So what we have done is we have just assumed this wave vector is in k direction, that means x direction, and x as it is minus omega t. Now what is del E? Del E is nothing but E naught into derivative of e power I kx minus omega t is nothing but e to the power I kx minus omega t into ik. Then what is del squared E? Del squared E will be ik squared into E naught e to the power I kx minus omega t. What is that equal to? Minus k square into E. This term is nothing but E. We have assumed it as E. Now we got del square E is equal to minus k square E. Now we want 1 dou square E by dou t squared. So dou square E divided by dou t square is equal to, now with time derivative. Time derivative of E means minus omega, I omega will remain. So minus I omega whole squared into E naught e to the power I kx minus omega t. So that is equal to minus omega square into E. So just substitute the values. Del square is nothing but what we got is minus k square plus k naught square into E is equal to 1 by c square into minus omega square into E. Now bring this negative sign here, which makes it k naught square. Okay, so this becomes, take the minus sign outside, so what it will become, k squared minus of k square minus k naught square into E equal to 1 by c square minus is there omega square E. So minus minus gets cancelled. What it is remaining is k square minus k naught square into E equal to 1 by c square omega square E. Now E and E gets cancelled. You want omega square. Omega square is equal to c square into k square minus k naught squared. So your option is C. So this is how you can do. Please don't waste your time doing second derivative of x, y and z. Don't waste your time doing that. Immediately you consider only one direction for wave propagation and start doing. Here is the question for you to practice. Both the questions are from electromagnetic theory, Maxwell's equation, and from charge distribution. Kindly try to solve the problems. We will be looking into the solution in the next lecture.